It's Throwback Thursday today, where we reach into the archives from like 10 years ago and grab a random video and re-edit it and turn it into a new video that I hope you guys will find interesting. Let's check it out. Hi, look what the cat dragged in for us to look at today. This is an RCA. It's a linear stereo, meaning it does not have the rotating hi-fi heads. This is basically 2 tracks of AM radio. This is an old beast, built by Hitachi. We'll pull the top off it and we find that it even has a tape in it already. It's a nice metal chassis on here. I was going to say a solid aluminum chassis, but that wasn't Hitachi's way of making things. It's a steel chassis with pieces that are bolted together. Good design. Very common problem with these were belts. Belts would fail. It had a Capstan motor over here. It's a belt drive Capstan motor. Well, we'll pull the bottom off it and take a look at that too. A good old linear power supply. These things here very seldom gave problems. This is a fuse here. This is a circuit protector. Kind of looks like a transistor, but it's not. It's a circuit protector, so they can go bad on them. And this one uses a linear regulator, kind of like that JVC for the power regulation. Looking at this board though, it looks like we may have some problems right here. It looks like water's gotten into this thing. This is a problem that this stuff goes conductive, it goes corrosive, and it goes conductive and causes us headaches. There's some more of it over here, so this has got to be all stripped off. If it's not causing a problem now, I'm sure it is at this point because it's turned kind of dark brown. This stuff was yellow when it was first applied, but it deteriorates, it oxidizes, and then it becomes very conductive. But my concern is this area here. Look at this. This really looks like we've had moisture in here, and it's been some electrolysis set up there. You can see it. You can see the burning here. So this circuit board's been wet. So we'll see what happens with this. We're going to pull the bottom off it and to look into the bottom first before we even plug it in. This is a belt drive machine. There's a belt that's off. I can see it right now. This belt's all chewed up here. It's fallen off. These were very common belts that fail. These are the loading belts. Most common problem you're going to find on a VCR of this vintage. The other belts in here are, you've got your Capstan belt. Now the Capstan motor drives the reels through this reel drive belt. It also drives the Capstan through this Capstan drive belt. And the play take-up spool is driven through this other little reduction pulley here. So we have a clutch assembly here. Sometimes this spring breaks. Right down here is that little plastic foot will break, which is what holds this spring in place, and then the unit will not engage into fast forward or rewind or go back into play. That's what returns the clutch assembly from fast forward back to play. Okay, one of the things we're going to do on this unit here is I'm going to put some lubricant grease onto the worm gear. As what happens is this dries up, and this is what causes it binds up in here. So we're going to put some of this newer grease in here. And we'll just work the mechanism through here a bit. As you can see, it's loading and unloading. This belt will probably get this machine working. But there we go, this mechanism is now loading. Well, we have a picture of a guy doing Taekwondo or something. Here, I'll show you what's on the screen. This is the tape that was in the machine. So, you can see the tape itself has got errors on it. It's got creases and stuff in the tape. So this machine actually has more problems than just the worn belt though. Listen what happens when I put it in the fast forward. We have a squeaking sound. And in this case, it's going to be the Capstan motor. Yeah, it's a Capstan motor bearing, it's howling. I'll show you some of the other things that need to be addressed on these units when you work on one of these RCA machines. A couple of things that need to be addressed on the mechanism on these is you have to lubricate. There's a bearing here, so you got to take off this bracket. on the capstan shaft, and we need to lubricate the capstan bearing. So how we do about that is, well, there's one piece there that needs to be lubricated. We actually have to pull the capstan shaft out to lubricate it. So to do that, we'll get the power off on the machine, of course, because we don't need it changing modes and trying to load up or anything. Take off the two belts, and you can pull the whole capstan assembly out. When you remove the capstan shaft, there's a little washer that fits down over top of it right here. You're just going to want to grab that washer so you don't lose it, because that's what keeps the grease and stuff and the oil in the bearing. So we're just going to put our hand in there to grab it and just pull the capstan shaft out. Just pull it all the way down. Now we've got that washer in our hand here. Now we can proceed to put a little bit of oil on the bearing here. So just get just regular, ordinary electric motor oil, just a drop down here or so in this area of the bearing. And now we can push the bearing back together, or push the capstan shaft back into the bearing, and put our washer on the top. We want to clean this black crap off of this grease off of here. So we're just going to clean out the black grease and clean it off of here. Replace it with grease. That's about all you need in there, just a spot of that. Then we can put our belts back on. Now we do want to clean the mode encoder switch on this unit, because those are always an area of trouble. Mode encoder switch on this unit is right down here. This is your mode encoder switch here. We're going to take off this little spring here. Take that out of the way like that. And now we can remove the switch and take it apart and clean the gunge out of the contacts and put some contact cleaner in there. So just the one screw holds it in place. Lift the switch out. And to open these switches up, they're quite easy. You just give them a little like that, just to push, flex down like that a bit. The switch will pop apart. Be careful not to drop the pieces out of it when it comes apart. Here's your contact here that needs to be cleaned, and we need to clean the gunge out of the back of that. We'll just wipe out the contacts here with the cotton swab. You can see the dirt that's coming off of here already. See that? These switches are quite dirty. They get quite a bit old up of oxide and stuff and dirt. And what happens is, as the switch is sliding back and forth to signal the microcontroller as to what it's doing, you get noise. And that noise causes the microprocessor to misinterpret the mechanical position of the mechanism. You can see what I've got off that one already. We're not clean yet. Once we got the contacts relatively clean, give them a shot of cleaner such as Neutral, just to seal them. This puts an oil coating on the switch, on the contacts, to keep them clean. Maybe put a little tension on these springs here a bit too, but the switch will snap back together. Give it a good clean, and now we're ready to remount the switch. Switch goes back in position. Now remember, it is critical when you tighten this down that you get the alignment correct, otherwise the mechanism won't respond properly. It only goes in one place. It snaps in over here. Get the spring back on here. And now we can check our alignment. And I just do that by moving the switch slightly so that it's lining up with the alignment mark. See the alignment mark there, the little triangle pointing at the indentation? It's the last indentation when you're in the stop position. Each one of these indentations indicate a different mode where the mechanism will stop. When it's fully ejected in the stop, it's in that one there on the end. Like all VHS mechanisms, it's a good idea to lubricate these things from time to time and get rid of this black grease that gums up. So I'm just going to wipe the black grease off of the mechanism here. Another real common problem on these RCAs was an idler tire that went bad here. This one here, it's actually got a gear. This is one of the newer style ones, so this one doesn't have an idler tire. Some of the other models, it actually had a rubber idler tire here, and that would wear out, and then you wouldn't get fast forward or rewind. I'm not going to put a lot of effort into this machine because I know that the Capstan motor itself is on its last legs, but we're going to just get it working. So there we go, we go into play, it threads the tape up, and it starts to play. And we have a picture here, so the machine's working. Here's the mechanism in play. I go into fast forward. Again, we've got that noisy motor. There's not much I can do about that. That's just the bearing of the motor is starting to wear out, and this motor is not available as a replacement part. Once again, there's the playback. Again, this tape is not in great shape. This tape looks like it's been copied a few times, and while VHS tape, all analog tape, loses its signal after a while. So what we'll do is we'll try playing back our alignment tape with color bars on here and see how it looks. Thread up my tape with color bars. The tracking is dead center where it's supposed to be, and it's hard to tell with this rolling shutter on here, but the picture actually is looking fine here. How's our tone? Yeah, we have tone. So I guess we can make a recording on this thing now and just see how it records. Well, we've got no video, we've got sound, but we have no video. So our problem is going to be on this video board down here. Remember the area of the board which looks like it's had water has entered the cabinet. It looks like that's causing us some grief. So I'm going to get my scope going here, and we're just going to see if we can quickly find where we're losing our signal. I'm not about to spend a lot of time on this unit here because this unit here is not a moneymaker other than the YouTube video. We look over on the scope. I probe the audio output from the tuner. There's our baseband audio. If I probe the video output from the tuner, there's our video signal. So we know the video signal is coming out from the tuner. And then from here it should go into a video switch and then go back into the circuitry. So let's take a look and see where we're losing it. But we know that the tuner is actually working. So it's something beyond the tuner. Well, I've decided to cut my losses on this one here. The fellow can have it back as a playback only machine. We have video going into this big IC here. This is a composite IC, and if I push on the IC like this, the picture cuts in and out. So we have a problem inside this IC. It's bad.
Down in the heart of the beat, we're rolling tonight. 12 all vids got the spark, everything's alright. From cars to the sounds that make you feel free. We're grateful for the love, you're the family. Late nights and bright lights, cruising the lane with every video drop. You're calling our name, so we sing it